What is going on, guys? Welcome back to the MG YouTube channel. I'm Malachi Grubb, CEO of Elite Automation League Properties and an investor in Tesla and other stocks as well. So if you're interested in those type of things, make sure you subscribe. Yeah, I take you guys into all different types of things, whether it's in, like our property investments. And I'm kind of just waiting for feedback to know like what some of our audience would like for us to talk more about. But I wanted to bring up today one thing that I never hear anybody talk about when it comes to Tesla and its FSD and its hardware. You know, we're always talking about the hardware, hardware 4 and going into hardware 5 computer for FSD. And there's now starting to be a mention of a new hardware change. And this hardware change is potentially one of the biggest and most important changes and improvements you could make to the vehicle's hardware. And it's revolving around the cameras. So as far as I know, Tesla has not released much information on the cameras, on the camera hardware, like when they're updating the cameras, other than like whenever we get something new, like a front bumper camera. But where something like a front bumper camera can be very useful, because any new angle that the vehicle can use in its perspective will give the vehicle more ability to see. And also, in my opinion, just for data standpoint, I think Tesla vehicles should have more cameras on them. Whether they use those cameras or not, let that be up to Tesla. And I understand there will be some more initial costs. Maybe they'll have to sell the vehicle for a higher price, or they'll have to take more of a margin loss on the vehicle. But with more cameras, they can collect more data, and overall be able to utilize that for training down the road. For example, I'm like 99% positive that they have found that without the front bumper camera, they have like a blind spot. And so that's why all new Tesla vehicles are starting to roll out with the front bumper camera. There's a blind spot there. They're starting to notice that, like, oh, if we engage FSD and like there's maybe a dog laying in front of the car, or a child, or whatever, right? Or there's curb or something that you can't see. Like when you're sitting in a vehicle, you can't see directly down in exactly what's in front of the vehicle. Sorry guys. So really, I think they should have more cameras. For another example, the Cybertruck, the camera is on the tailgate, which is cool and all. However, like in instances where I need to have my tailgate down, I then lose my FSD, which really is kind of a bummer. And maybe, you know, the caveat to that is, well, if I have 2x4s or something sticking out in my bumper, then maybe I shouldn't have FSD activated anyway. However, on the flip side, if I have a couch or something like that that's sitting in the same dimensions as my like bed and my tailgate, you know, I feel like you should be able to engage FSD. So if there was like a rear bumper camera, then they would be able to resort to using the rear bumper camera versus the tailgate camera for, you know, basically a substitute for the tailgate camera. But this is really not what I'm talking about in this video. What I really want to showcase is the actual camera sensor itself. And again, why is the actual camera sensor itself so important? It's because that is the input device. That is the device that captures all things around it, okay? And I actually have a very vast background in cameras, not necessarily going down to the extreme hardware level to the sense of, you know, engineering a camera, but to the point of dealing with cameras on an engineering level, and dealing with things like exposure, and dealing with basically all your different camera settings, right? I'm getting a little bit rusty on my cameras. I haven't had to go in and hard fine-tune cameras for a while now. But yeah, you know, you have your exposure, your aperture, all those good things that normal like photographers and stuff are aware of. But on an engineering basis, when you take that into a machine, there's all kinds of tools that you can run on it. You can run like light and dark tests. You have like your dynamic, not dynamic rate, whatever the dynamic thing is again. So, but the dynamic basically is meaning like how much I can pick up between like shadows and stuff like that. Like this gives the higher dynamic range that you have, the more ability you have to either detect shadows, to see light, or not be blinded by light. And so there's a lot of things that are in the real world that a camera has to deal with, okay? And some of those examples are, you know, you have your highlight situations, you have your low light situations, you have your like dirty camera situations, you have rain situations, and to be honest, like it works extremely phenomenally well with the existing cameras. Like whenever it's raining and it's like piss poor raining and like I can barely see, but somehow FSD can still function. If you can give the camera more ability to see more things and or exclude more things, this gives the camera overall the ability to see the world better. Like for example, let's say for instance you put a camera on there that had night vision. Now given this could be very expensive and you know, definitely not worth it. And honestly, in my opinion, talking about more cameras, I could see in the future where you have a suite of cameras. So like the same way you see on your iPhone or whatever phone you have these days, almost all phones have like 2, 3, 4 cameras on them. And the reason for that is because that sensor is engineered to do certain things. Some sensors are engineered to like see further away. Some sensors are engineered to see up more up close, and then some sensors are meant to give you that like wide angle lens. Now, for the most part, those sensors are made for your zoom, right? And so just that alone, Tesla could do something like that where they have each camera location that you see could have 3 cameras on it. And then you get your zoom, your wide angle, your standard view, and now you have 3 different zoom angles. So if there's something over here and you're like trying to look down a road, they could potentially do a zoom on one of the other cameras and then be able to get a better, higher resolution view of that particular instance, right? So as an AI, you could say, hey, I'm trying to see over there. I can't tell if that's a car coming. Switch cameras, zoom in. Okay, that's not a car. Let's go. You know what I mean? Especially in those instances where the vehicle is like sitting and waiting for a long time and it's trying to like judge and calculate if it can go just due to like high traffic or something along those lines. And so that's just one example of a camera that gives you the ability to do a zoom, or it's one example of a feature of a camera, right? And a lot of times that's done with lensing and not necessarily the camera sensor itself. Now it can be the camera sensor itself, but a lot of times that's lensing. Now there's other cameras that can do other things. Going back to like night vision, you could have a camera that's dedicated for night vision. So again, at nighttime, it can kick in that night vision camera and then just be able to see like, you know, an owl at night, you know, see like a cat at night. And there's other characteristics about cameras as well, where it's like a give or take type of scenario. And what do I mean by that is you might be able to trade something like color and trade that for definition. So almost all sensory devices trade one characteristic for another. Now, as cameras get better and better, that gets wider and wider. So you have a standard camera that can cover more edge cases than, you know, a camera could 10 years ago. So again, everyday cameras are, you know, evolving and becoming more advanced in their capabilities. However, they're also becoming more advanced in their capabilities and their specification, meaning that night vision only camera, a white and black camera, which you'd also call a monochrome camera. And so like going back, I want to dive into that monochrome camera for a second. A monochrome camera, you might lose color, but you gain more definition in things like your definition. You gain more definition on a white to black scale. So like whenever I've done engineering with some cameras, sometimes you would well, sometimes we just use monochrome cameras, but you could switch to like a software based like monochrome mode as well, and it gives you light and dark. And so I just want to really hone in on a tool that you could use, but if you have a camera that's specific for it, then the hardware itself is better for it. And because I don't want to confuse people too deeply with the engineering things, but I kind of also want you guys to understand what I mean on some of these like engineering levels. So some of these tools, we might turn it to a white and black mode. Why? Because in the white and black mode, we can detect things like a hard line much easier, right? Because, and you'll call this grayscale as well. So if you have two objects that are sitting side by side in a grayscale, let's say for instance you have two objects that are green sitting against each other, right? Let's say you have a green vehicle and there's a building behind that vehicle that's green, and you're trying to look at that vehicle. It might be very hard to distinguish the two greens from one another in color, which is, it's a very funny perspective. However, if you flip that to monochrome, aka black and white, there might be a very distinct difference. And you could even put in, again, this is talking about the tool side of it and not the hardware side of it, but the hardware, if engineered for it, will have the same characteristics. But instead of trying to do it on the back end in software, you're taking it directly in the sensor. You're taking the information directly in the sensor, and the hardware is optimized for it. Again, going back to monochrome, whenever you flip that to monochrome, those two greens that are against each other, you might be able to flip it to where like one of them's almost completely white and one of them's almost completely black. So it is a definitive like 1 and 0, where that's how much differentiate there is between the two different color greens. And as a human and even as a color camera, you may not be able to detect the difference. But again, whenever you put it in that monochrome, you're able to detect that difference very significantly. And going back to it being a grayscale, maybe it's not white on black, but maybe it's two different shades of gray, and those two different shades of gray are enough shades away that it becomes a very distinct number. So I'm just using random numbers, but like let's say if 0 is white and 100 is black, then maybe the building is 30 and the vehicle is 60, and from those two you can basically make a hard decision on which is which, right? And here's another thing that I want to put an example against, in the nature. So I mentioned the owl with night vision, and also with colors. So I'm not exactly sure what animals know what colors, but it goes into perception and how your brain perceives things. But like I might look at grass and say that grass is green, but like a dog might look at that grass and see a violet color, and another animal might look at it and see another color, right? And that's due to perception. And basically the camera takes in this data, and then it perceives it and changes it to we train it to be what we think it is, right? We train it to be green. We train it to output pixels on a screen that are green. And even the camera doesn't even necessarily see that they're green. It's just that we output that perception on a screen. So one thing that Tesla is doing that's different is they're just doing a direct photon count. So with the AI may not be seeing things in color. This AI may be seeing things also in like potentially an ultraviolet realm. And so also another thing is, can you have the camera just see in more spectrums of color, right? So as a human, we see different hues and stuff like that, but you go and you look at somebody who's like colorblind, right? Sometimes they have trouble seeing like two different greens to one another, or they'll see a green and they see blue. And how is that an advantage? How is that a tool to be able to make the system function better? Well, if you can open up those spectrums to where, blue is not just blue, but you break it down, and again, computers and vision can already do this to a degree, right? But it's really all limited by the hardware of the camera. And everything else is done software. So if you try to do things after sensor in the software, you're basically working with a limited amount of data. If you took these same cameras that are on a Tesla and you swapped out some lower level camera, the FSD would immediately start operating way worse, right? Because it won't have like the ability to have the dynamic range that these have, or it won't have the ability to maybe have as wide angle of a view, or it won't be able to, let's say, oh, what's the word for it? It won't be able to, I'll say, reduce the light. Like if you have sunshine shining in, I'm trying to think of the word for it. That slipped my mind right now. But there's a word for it where you basically cancel out like that bright sunlight and then just examine the things around it, right? You're basically able to tone down that light to where that light becomes a dot on the screen versus like blowing out your entire screen where you can't see anything at all. And I'm just bringing this back to our human perception, because again, Tesla is taking that sensor data and doing direct photon count, means AKA they're not converting it to human image, right? They're not converting it into a way that you see it on a screen. The AI is perceiving it in a completely different way. It might be the difference of the AI is perceiving it in a way that a dog would perceive it versus a human would perceive it, just due to color. Now, with that caveat being said, cameras are also designed with, human perception in mind, right? Most cameras, like the mass market of cameras, because like whenever you snap an image, you want your greens to be green and you want your blues to be blue, and you want your camera to be able to collect that data to match the human perception perfectly. And a really good example of this is if you look at like a Sony camera versus a Canon camera, you'll notice that people have preferences over the Sony versus the Canon. And I can't remember exactly what it is at the moment, but one of them has like more truer colors. I want to say it's Canon. Canon is, I believe, the one that has more truer colors, meaning whenever you take a picture and then you compare that picture to real life, those colors match real life better than, like, let's say, for instance, Sony camera does. Now, again, talking about camera comparisons, Sony may do better in other things like dynamic range. Maybe it picks up shadows better, and this goes back into like sensor selection and why them changing that sensor hardware could be such a big deal. It honestly could be like a game changer. And as Tesla tries to run different tests on different cameras, and as camera technologies advance, things like this are really what's going to help push things like FSD forward, especially in those major edge cases. The sunlight, the rainy conditions, snowy conditions, all these different things, right? Let's go. Snowy condition just popped in my mind. Okay, I noticed the FSD was acting a little bit weird in snowy conditions. Well, one thing that people may not think about with snow is cameras can get blown out by snow. Blown out means the screen goes white. It can't see anything because everything's too bright. Why does that happen? Well, it's a dynamic range issue. The sun's coming down, it's bouncing off the sun, everything's so white. And you may notice that sometimes if you're like inside and you go outside on a sunny, snowy day, you might have to squint your eyes because it's like so bright outside. Everything's so white. Well, that's the same thing the camera sensor has to do, is it has to squint its eyes to be like, whoa, hold on, what's going on here? And when it has to do that, it might have to tone everything down so that things are not too bright. But in the instance of toning everything down so things are not too bright, it also makes things too dark. So your road might turn like black, even though it's not a black road. It might, and when I say black, I mean you could have the yellow stripes in the road turn black because it had to tone things down so much that that it just now can't see things that are actually there. And again, this goes back into this. One of the limitations of cameras And, you know, if you can do things like just improve the camera sensor itself and or add more cameras. See, adding more cameras adds expenses. One of my predictions, one of my predictions is at some point in time, Tesla will continue to add more cameras to the vehicles. And I think at some point in time, the government may start forcing safety on autonomous vehicles. So what's going to happen is we're going to have autonomous vehicles, okay, in this next year. We already have autonomous vehicles, but they're going to start becoming very popular in the next year to 2 years, okay? You're going to start getting them in every single city. I would say within 5 years, every single city on the planet, well, not the planet, at least the United States, and a lot of the planet, will have FSD autonomous vehicles, okay? Once that happens, now the government's going to look at everybody that's doing autonomy, and they're going to say, what's the safety data on your vehicle? How often are you getting in a wreck? Okay? And they're going to look at Tesla specifically. They're going to look at Waymo. They're going to look at anybody who is a autonomous vehicle operator. They're going to look at all their safety data. They're going to tell the individuals that have autonomous vehicles that are maybe not as safe as Teslas, and they're going to say, hey, you guys got to step this up. We need to see like a 20% improvement in safety every year, or else you're going to have to shut down. You're not going to be able to operate. You're just not near safe enough as a Tesla. They might come to Tesla and say, hey, Tesla, look, we know you have one of the best safety ratings in the US, in the world. However, we want to see you improve on this. You're not going to be able to set it and forget it, right? We want to see you improve on this. This FSD for the next 5 years needs to get 5% safer every single year. Okay? And they could call out a certain characteristic. Maybe in the nearer term, it'll be, hey, you guys have a lot of wrecks whenever it snows. You have a lot of wrecks when it rains. I need you guys to really start honing in on that and make it so that the vehicle is much safer during those conditions, right? And so, with that being said, there might be hardware limitations, aka, you know, this sensor only has a certain dynamic range, aka it doesn't have a good enough field of view. Maybe the field of view, like angularity wise, like it has 180 degree field of view, but like on a zoom aspect, it doesn't have a crisp enough image would be the main thing. It doesn't have a crisp enough image to see in detail enough what's going on, you know, out in the distance. Okay. So point being is there's going to become limitations with the current hardware, and even with the optimization of cameras. Cameras have been around for a long time now. So, you know, we're kind of already hit that curve where cameras are not getting a lot better very quick. Now, they got very good over the past, like, 20 years, you know, extremely good. I mean, they went from being, like, garbage, potato phones, potato cameras, to, like, now, like, just so crisp, like, they don't even need to get much crisper, right? On the flip side to that, we're at that higher end where the cameras can't get that much better. Now, again, Tesla can engineer the specific hardware, and if they're using their own camera sensor, then, you know, they can, or if they have a partner that they're working with, they can keep trying to optimize. We need to optimize this for snow. We need to optimize this for rain. We need to blah, blah, blah. And so they could try their best to keep optimizing that. But at some point in time, you know, the camera company's going to say, or Tesla, we can only optimize this much. If you want something that's going to be like extremely good for snow, we're going to have to add a sensor that is dedicated just for snow. And then we're going to have to start training on that camera that's just for snow. If you want to get this much better at night, we're going to have to put in a camera that's designed for night, and we're going to have to use that camera during the night. Also, too, the sensors that we have in here, I'm not exactly sure like how many megapixels and stuff they are, but they're not the highest in megapixels. I mean, your Canon camera has a much higher megapixel count than these cameras, I believe. These are like closer to like your phone's camera. And a lot of that's to cost, right? Because if this camera costs $250 to Tesla, and you have whatever it is, 8 cameras on this vehicle, 250 times 8, versus if these are $1,000 each, now we're at 1,000 times 8. You can see where that really increases the cost of the vehicle. However, like as we go to autonomy, as we go to like people not necessarily owning vehicles into the future, I definitely think we could have a scenario like that where people don't, they don't own as many vehicles. And so in that instance, it makes sense that you spend the extra money on that better sensor, that captures more megapixels. Now, maybe when you take it into the AI, you throw away a lot of that data. You don't actually use the full gambit of that sensor. And why would you do that? The biggest reason why is for processing power. Because if you're using a 30 megapixel sensor, that's a lot of data to transfer, right? The bigger the sensor, the more data you're transferring, the slower things are going to operate. So I wouldn't even be surprised if they're reducing the data that they're using on the cameras now. And then again, this is where like having better AI computers could really help. Because if you have a better AI computer and you can process data faster, you can use a higher end sensor. And maybe that's why we're not getting a better camera sensor or an upgrade in the camera sensor until this AI 5. Maybe AI 4, this is literally all the compute that you could put into an AI 4, right? And some people don't understand that. And also, too, whenever it comes to compute, I'm not saying that the computer doesn't have the ability to process a higher end sensor. However, what you get with the higher end sensor and the same computer is latency. Latency meaning it takes more time to process the same image. So, for example, if they're processing the image in like 1 millisecond, and we increase this to a 30 megapixel, and now it takes 50 milliseconds to process this image, that latency between camera seeing it and the vehicle being able to make a decision might be the difference between an accident and not having an accident. So that's why you can't just expand it, have more latency, because latency is one of the most important things to avoiding accidents. Now, I do think that whenever it comes to like vehicle and vehicle driving, like you actually have like a second or two to react to pretty much all driving conditions, unless it's caused by somebody else. So I think there is leeway there. I think that they're just trying to crunch down that latency as much as possible, so that way the vehicle is able to avoid all accidents. And this is another thing too that's like a caveat for the future, is like as all vehicles become autonomous, things on the roads might completely change. We may not have traffic lights. All the vehicles might talk to each other so they all know where they're at. They might say, hey, I'm going to get into the right lane. Move out of my way for me. And the vehicles will make a space for them. I think there will definitively be a communication architecture, and we won't be based just off of like vision and like the onboard neural net. I think I think if they get that part, and they're going to get that part accomplished, where they're able to just onboard, AI navigate the roads. The thing is, like whenever I was talking about like a governmental push that you need to get X amount safer, I think at some point in time that gets us to a point where one of the ways you make it safer is not improving the hardware of the vehicle per se, not improving the existing hardware, but to add some hardware and or just communication protocols, this is where I think it's going to be. There's going to be communication protocols where the vehicle talks to other vehicles, and every vehicle knows exactly where it's at, and everything's kind of like encoder based, and so that there's almost like a 3D map of every vehicle in the world in like a digital simulation, a digital twin. I don't know if anybody's ever heard of a digital twin, but I think at some point in time we'll get to like where there's a digital twin of basically our world and of all the vehicles in the world, and you're going to be able to do other things with this other than just communicate with the vehicle. You're going to be able to communicate with McDonald's and then tell the app that, like, it's the vehicle's there, which you can already do with GPS, but you're going to be able to do this on another level. You're going to be able to pull up to the drive-through window and your vehicle tell McDonald's, hey, I'm at the window. It's going to have your order number. It's going to have your vehicle. Your vehicle's going to be sitting right here. Boom, boom, boom. You know what I mean? And then that way, like, McDonald's is, you know, ideally not giving out the wrong orders and stuff like that. Here, you know, boom, right above the window. This is what that person's order is. This is that person's name. It pulls up to the next vehicle. Now, again, they're going to be able to handle a lot of this internally, but as we reach a higher level of autonomy, you know, if we have an Optimus robot that's handing us a bag outside of the door, sure, the Optimus can have its own AI. But things become very definitive when you have a communication protocol. When you say, hey, I'm here. It says, okay, I'm giving it to you. Getting off on side tangents. I always do that in these videos because, you know, I'm an engineer at heart. But, yeah, let me know what you think about, you know, Tesla and doing, or upgrading their cameras. And, if you think it's going to make a difference, if any of this made any sense to you. I'll catch you on the next one. Subscribe if you're interested in videos like this. And, yeah, peace.